Hello, good morning, students. Today, the topic that we are going to be discussing in advanced networking is VLANs or virtual local area networks. So again, this might be another topic that you would have uh, come across previously. You may have even looked into this in some detail. Today, we are going to go a bit more detail into the topic and see how VLANs are an essential tool in many of the networks that we may be using or we may be setting up. So the main idea behind VLANs, the main thing that we get out from using VLANs is our ability to create networks that are physically spanning across different spaces. Say, for example, if we look at the diagram here, we have a building of 3 floors, and at each floor we have a switch, and then all those switches are aggregated to another switch and then to a router. So here, with each floor, it is physically connected together across each floors, and then again they are aggregated at the switch level and then going to a single router. So essentially this can be a single network. But what we can do with VLANs is, with each of the devices, it may be possible for us to segment them into different networks. Say, for example, within each of the floors, we can go and selectively assign certain connections, certain nodes as different departments, like belonging to the IT department, belonging to HR, or belonging to sales. Likewise, we are able to segment them into different local area networks or different virtual local area networks, even though they belong to the same physical local area network. So essentially what happens is, with VLAN, we create another layer of, or another concept of a local area network at a layer 2 network, and it would in many ways function as a separate network, as if we had constructed a physically separate local area network. But in reality, they can physically exist in any setting or any setup. So it is more of a configuration or like a settings based network, which can exist on top of a common or similar type of a physical network. So what we can see is, like, within VLANs, again, even when we think about how packets are going to go between networks, they would still behave as they are separate networks. So if you are sending broadcast packets or something like that, their broadcast domain will be within the within those VLAN devices only, but that itself can span across different physical LAN segments. So again, The physical LAN segments in this case are the each floor. So first floor, second floor, third floor are different physical LAN segments. But if we take VLAN to ITV LAN, it is something that spans across all these three floors or these three physical LAN segments. So if we take the broadcast domain for VLAN 2, that is going to exist across these three floors of the physical building. So why do we use VLANs, or what are the main reasons why we use VLANs? One of the advantages that we can get from using VLANs is security, because even when we have devices connecting from the same space, they may belong to different segments of the organization, and they may need to access different services, different parts of the network. For example, if we take the university, for example, in university we have a number of different types of users. We have the teaching staff, we have the administrative staff, we have students, and sometimes we may even have guests who may be visiting the university. All of these people may be accessing the same networks. It is one impractical, not efficient, or it could be even costly if we are to set up different networks to these different groups of people. So we have to go with the same physical network to interconnect all these different classes of users. But with that, we come to a situation where, say for example, the teachers and the students are now in the same network, they're using the same network, but they may not need to access the same set of services or servers or things like that. So there may be different requirements for each of these user groups to do different things. But as they are in the same physical network, it would be possible, it's plausible for them to much easily get across these different networks or different parts of the network, and that could be a potential security risk. So what we can do there is, from a security point of view, we can segment these users into different VLANs. Say for example, the teaching staff, the faculty belong to VLAN 10, the students belong to VLAN 20. So then we can only allow these people from these different VLANs to access different things. Then we can do further routing configurations to limit who can go from where to where in terms of the network. But they are segmented using VLANs. So that is one of the benefits that we can get from using VLANs, is to get a bit more improved security in our overall network. Then on the same way, we can also reduce cost, because again now we don't need to have different physical networks to do different things. We can utilize the same physical network to carry different traffic. So again, one of the use cases may be we are having IP phones and we are having the data network, or rather like different connectivity to the internet, for example. And both of these things are carried across the same physical network, but then again they are segmented through VLANs to route them appropriately. So again, like the main sort of set of benefits, majority of the benefits that we get from using VLANs are around improving the efficiency of the overall network from different perspectives. So we can again we can have like performance advantages. We can define our broadcast domain in a manner that it is not going to the whole of network. If it is set up like that, the management can be efficient. So again, we can manage them from a single point. So there are a number of advantages why we prefer to use VLANs. So again, if we take the example of our faculty, that's again set up using VLANs as one of the core components. So now let's look at when we look at VLANs, we can sort of categorize a number of different types of VLANs. So if we take a switch where we are configuring the VLANs, there will be a default VLAN, which is where anything that is not assigned to a specific VLAN will fall under. Because if you are using VLANs, then all the ports, all the devices attaching to the network should have a VLAN associated with them. So to do that, we will have this default VLAN, which would be all the ports that are not specifically assigned to any VLAN. So if we haven't configured any VLANs, all the ports on the switch will belong to VLAN 1. So then in addition to this, we have a number of different additional sort of VLANs. So data VLANs are the ones that we specifically create. So these are the faculty VLAN or student VLAN or IT VLAN, sales VLAN likewise. These are the VLANs that we create for specific user groups. So those are the data VLANs. Then in our networks, we may also get traffic that come into the network from something that is not VLAN enabled. So we may connect number of switches, and one of those switches may not support VLAN. So when it is connected back to a switch that is enabled with VLAN, that traffic coming from the non-VLAN switch will not carry any VLAN tagging. So when it comes to the VLAN enabled switch, it will have to be assigned a VLAN. So that is what we would have as the native VLAN. And by default, normally native VLAN is also the default VLAN. So native VLAN will be assigned VLAN 1, which is the default VLAN. So anything that is again connecting. But this is something that we can change. If we want to change it to something else, we can change to something else as well. Then we can also have a management VLAN. So again, when we think about all these different networks, and in the previous weeks we also talked about how we go about configuring switches or configuring routers. So then when we think about configuring these things through the IP network, so now all these routers and switches also have their own configuration ports attached to our network. So those devices are also part of the network as sort of nodes, which we can get to for configuration purposes or management and configuration purposes. So those devices, we don't want them to be part of the same data network or the data VLANs. So we don't want them to belong to any of the data VLANs, but we want them to belong on a separate management VLAN. So this is mainly traffic that is relevant to network management. So that is what it's going to carry. Things like SSH and all that relevant for configuration and intercommunication between these devices. So that would be carried through management VLAN, and again by default it could be VLAN 1, and it could be changed to something else as well. So that is the management VLAN. So then, if you look at this diagram, we can observe a number of things. So we have a number of devices with specific VLAN assignments. So we have VLAN 10 for faculty, we have VLAN 20 for students, and we have VLAN 30 for guests. And with this, we have two switches where each of these VLANs are attaching to. So if we take switch 2, for example, there port 6 is VLAN 30, port 18 is VLAN 20, and port 11 is VLAN 10. So each of those ports are essentially carrying traffic belonging to a single VLAN. So port 11 will carry traffic belonging to VLAN 10, port 18 will be VLAN 20, port 6 will be VLAN 30. So the same thing also applies to the other switch as well. Switch 3 also has the same scenario. But if we take the connections between switch 2 and switch 1 and switch 1 and switch 3, that belongs to more than one VLAN. So for example, the connection between switch 2 and switch 1, it is going to carry traffic belonging to all the VLANs, because it has to take and carry forward the information across to the other side. So it has to carry all the VLAN information. So that is the type of connection that we would identify as a VLAN trunk. So a VLAN trunk is essentially a point-to-point connection that carries more than one VLAN. So we would use VLAN trunks when we are interconnecting switches and want to carry forward all the VLAN information across those switches. So this is important because if we take the VLAN 10 for example, we need to have communication between VLAN 10. We need to have broadcast across VLAN 10, that network. So that is VLAN 10. We need to have communication between these. So for that communication to happen, the information should be able to travel from switch 2 to switch 1 to switch 3 seamlessly with carrying the VLAN information. So that's why these connections need to be able to handle that information. So that is what we identify as a VLAN trunk. Then one of the things that we do with VLANs, or as a result of using VLAN, is it can control the overall size of the broadcast domain of the network. Say if we take again this example here, If we don't have any VLANs, all of these devices will belong to the same broadcast domain. So when we take a very large network, like a university or like an enterprise environment, that overall network size, the entire network size is going to be very large. And if the broadcast domain is also that large, uh, it it is going to potentially go to all the ports of the network, which could be inefficient of the overall network. But by segmenting this network into a number of different VLANs, now the broadcast domain is only limited to that VLAN. Say for example, if we send something from PC1, if there's no VLAN, it should go to PC2, 3 and 2, 4 and 5. Whereas when we have VLANs enabled, it only would go to PC4. So with VLANs, we can limit the overall broadcast domain, and that can benefit in terms of the overall network efficiency. So to use VLANs, so these are some we sort of looked at the number of benefits and why we use them. So now, if we go into looking in a bit more detail in terms of how we use VLANs, the VLAN information. So whenever a frame is forwarded across the switches, the information that it belongs to a particular VLAN should be attached to that frame, and then it will be communicated, or it will be transferred across. So this activity of including the VLAN information is known as VLAN tagging. So we tag with the VLAN identification. The VLAN ID will be included with the frame. So to do this, the protocols that we will use are known as VLAN trunking protocols. So essentially, these are the VLAN protocols that would help us include VLAN information, and the most commonly used VLAN trunking protocol is the 802.1q protocol. And there, the VLAN trunk information is included. In addition to the VLAN ID, there are a few other parameters, and then it is included with the frame before it is communicated across the network. So we looked at this VLAN trunking and VLAN tagging, but we also briefly touched upon native VLANs when we were looking at the different types of VLANs. So with native VLANs, what essentially happens is we have so with our switches, the different switches that we have, whatever the ports that connect to those switches, we can associate with them with a particular VLAN identifier. But if we have a frame, or if we receive a frame and that is not identified or that is not tagged with a VLAN, but it is connected to the network. It could be through a switch, or it could be an untagged trunk, depending on the nature of the network. That is possible. So then if it belongs, it will be added to a native VLAN. So normally native VLAN is also by default can be VLAN 1. So if we have a native VLAN, if we have devices attached to native VLAN, so then those packets will go forward to those parts of the network, the VLAN 1, it will go to that, because by default that's the native VLAN. But if we don't have anything configured with that, then that packet will be dropped. The packets could be received, but if we don't have any corresponding VLANs associated with that VLAN tag, those packets, those frames will be dropped from our network, because we don't have any devices that we can identify with that VLAN identifier. Then another type of VLAN that we are most likely to come across is known as the voice VLANs. So voice VLANs are things that we would come across in many enterprise environments, because this is what we use when we are using voice over IP uh, uh, typed phones essentially. So what we have is we connect both voice VLAN or rather these IP phones and the PCs directly to the switches. And the most common scenario how they are connected is normally we get a connection coming from our switch to say an office room or a cubicle, and there it will connect to a voice over IP phone, and then a PC will be connected to the voice over IP phone, another port on the voice over IP phone, so that will function as an internal switch that is carrying forward the other data network. So the reason why we put these phones on a different VLANs is because we have slightly different requirements when it comes to this type of traffic. So it could be voice over IP, or it could be even video conferencing, these type of applications. We would like to have network communication with low latency. So we don't want to, we want to avoid delays, and we want the traffic to be prioritized. So to configure those things at the other parts of the network, we should be able to identify this traffic separately. So that is what we do. Even at the point when they switch, they already identified whether they belong to the voice network or the data network. So the data networks, that is the PC, that will come to the voice over IP phone, and there that will be tagged with the data network. The rest of the traffic that is coming from the phone will be tagged with the voice VLAN ID, and then they will be forwarded onto the switch. So then in the rest of the network, the other parts of the network, we can configure things appropriately to handle these traffics differently. So that is one of the more specific types of VLANs that you could come across in most enterprise network scenarios. So we essentially would do this within, so that tagging part would essentially happen within the phones itself. If we have devices that function like that, so what happens is the phones themselves would function like a switch, and they would do the initial tagging, separating from the voice VLAN traffic from the data VLAN traffic, and then the connection, essentially the connection between the phone and the switch, will function as a VLAN trunk because it is already carrying traffic belonging to more than one VLAN. So that is what we would have in most sort of a typical voice over IP phone and a PC type setup in many sort of office environments. So now let's look at some of the basic things that we'll have to do to configure and set up such VLANs. So the first thing that we would need to identify when we are configuring VLANs is identifying what is the VLAN ID that we are going to configure with. So that is we have to specify what are the VLAN IDs we have. So there are some of the VLAN IDs have different purposes. We can use them for different, some are reserved, some we can use on our own, so with our own discretion kind of a thing. Say for example, the two main categories are the normal range and the extended range. Normal range is from 1 to 1005 and 1006 to 4096 is the extended range. The main difference between these two is the normal range, the configurations are stored in the device itself, whereas in the extended range, the configurations are on a temporary running configuration. So they are not stored on the permanent flash memory. So that is one main difference. And with extended VLANs, again, any of the VLAN trunking protocols, they don't particularly learn about the extended VLAN. So the most of the time when we are configuring, we are most likely to configure in the normal range of VLANs. And within that normal range, we also have 4 additional VLANs that are particularly reserved for specific purposes. And that is, again, you will see by default setup in our devices, in our switches. So when we go into switches and do a show VLAN brief, we will see all the ports of the switch attached to default VLAN 1. So again, that's the default configuration. In addition to that, ports, rather VLAN IDs 1002 to 2005 are assigned to some other specific VLAN. So again, this is what we would have as our default configuration. So when we want to create a VLAN in a Cisco switch, for example, we would go into configuration in the switch. We'll go and in the configuration mode, we'll go to creating a VLAN by specifying a VLAN ID. So that's the number. And then after that, we can also specify the name. So VLAN 20 is the student VLAN, or we had like VLAN 10 was the faculty VLAN. So we have to specify the VLAN ID, which is the number, and also a unique name, which is the VLAN name, a text name, an identifier for that. And then once we have set up these VLANs, like the student VLAN, and likewise once we have set up these VLANs, then what we can do is we can go and configure each of the ports, saying it belongs to what VLAN. So we can go to each of the interfaces. Say for example here, if we go to interface 18 and we want to assign that PC2 to student VLAN. So what we do is we go to again configuration, we go to that particular interface, and there we enable the port to access mode, and then we specify it to VLAN 20. So now that port will be assigned to VLAN 20. And if we have, say for example, sometimes what can happen is the same interface or the same port can carry a number of different VLANs. So in this example, if we are connecting a data device, a computer, through an IP phone coming to our switch. So then when we are configuring that at our switch point, now that is again that is going to be a trunk between the switch and the IP phone. Connection is essentially a trunk, in this case the connection between the switch and the IP phone. So basically it is going to carry the traffic belonging to the voice network and also the data network, the student VLAN. So here when we are configuring, what we'll have to do is we'll have to create both the VLANs. That is, we create VLAN 20 as student and VLAN 150 as voice. And then when we configure the port, we configure the access VLAN, or which is the data VLAN, as VLAN 20, and we specifically configure the voice VLAN as VLAN 20. So any traffic that belongs to a voice network will go to VLAN 20, and the data network or the data VLAN will be the VLAN 20, or rather 150 and 20. So that is, so once we define our VLANs, then we'll have to go and specify which VLANs these different ports belong to in a switch. And say for example, if you want to reconfigure them, say if we want to say remove one of the ports from a VLAN, again we can go into the interface and again remove it from the assign it to no VLAN. So if we assign it to no VLAN, it will go back to the default. And in terms of VLAN configurations, we can look at a number of things. So if we go into each of the VLANs, and there we can verify what is the sort of the configuration of that specific VLAN. Say for example, if we look at student VLAN, we can look at what are the memberships or what are the ports that are assigned to student VLAN. So in this case, 11 and 18 are assigned to VLAN 20. Or we can look at what are the different, how many VLANs we have, or we can even go into specific ports and see if they are if a specific VLAN is assigned on a specific port or an interface. Then one of the other things that we will need to configure is these VLAN trunks. So VLAN trunks between switches. So in this case, a VLAN trunk between switch 1 and switch 2, because it needs to carry traffic belonging to all the VLANs. So what we need to specify is what are the VLAN traffic that is going to be allowed in that particular trunk. So we have to specify what are the VLANs that are going to be part of this specific VLAN trunk. So first thing we have to make is we have to make that port, make that interface a trunk port. So instead of when we are normally configuring, we are making them access interfaces. Now we are changing the mode to trunk mode. And then within the trunk, we can specify the native VLAN. So we specify VLAN 99 as the native VLAN in this case. And then we are also allowing VLAN 10, 20, 30, and 99 as part of that trunk. So only those VLAN traffic will be taken across this VLAN trunk. So any other VLAN, any other tagged packets will not be carried across this trunk. So that is the configuration that we do when we are configuring VLAN trunks. So one of the things that we have to, when we are thinking of troubleshooting VLANs, so one of the first things, like maybe related to configuring VLAN trunks, is that any of the trunks that we configure should be able to carry traffic belonging to the trunks that we need to communicate. But more than that, the typical IP configuration should be correct, because the within each VLAN it can have its own IP, its own network, because each VLAN is a separate network. So it can have that its network space, IP space for that particular network, that's particular VLAN. So any device that is belonging to that network or belonging to that virtual network should have an IP address belonging to that network. So in this case, for example, PC1 and PC1 and the web server and the PC4, or the all of these are in the same VLAN. All of them are in VLAN 10. So then they should be configured with IP addresses that belong to the same network. But in this case, we have configured them in two different spaces, because VLAN, the PC1 is in 172.172 network, the other one is 172.17 network. So these are two different networks we have configured, even though we have put them in the same VLAN. So there it will not be able to communicate. So that is one sort of trouble that we may come across, that is not configuring the IP information correctly according to the VLAN that we are configuring. Then another problem that we may come across is relevant to VLAN trunks. Say, for example, if we take the trunk between switch 1 and 2, if we take this VLAN trunk, when we think about communication between PC1 and the web server, this trunk should be able to carry traffic belonging to VLAN 10. So only if it can carry traffic belonging to VLAN 10, we can effectively communicate between PC1 and the web server. So when we are configuring that trunk on these switches, we should allow VLAN 10 as part of the allowed VLANs. So again, if we miss that configuration, again, that communication could be affected. Then one of the other troubles that we may come across is when we think of a network like this, we have a number of switches in this network. And say if we think about communicating between PC1 and PC4, the communication between PC1 and PC4, it needs to go through all these switches. So each of these switches and the associated ports that are connected, the trunks, all of them should have all the relevant VLAN information. If any one of these things are missing any of the necessary VLAN information, again, we will not be able to establish a connection appropriately. So what we can do is we can go and check each of the ports and see if they have VLAN enabled on them, and see if VLAN is active on them. And then we can check the trunks and see if VLAN is correctly configured on them. So these are some of the, again, troubleshooting steps we can take, because that's essentially the set of configurations that we do. So we go and check them to see if they are all in place. So again, as I said, so we check the interfaces to see if the interfaces are correctly tagged, correctly configured with the necessary VLANs. Then we go into trunks and we check whether the trunks are specified correctly with the correct native VLAN and other allowed VLANs are configured appropriately. So again, we verify the trunk to see if that is the problem in our network. So again, with each of these parts, we verify whether the specific VLANs are able to communicate through those. So specifically with trunks, again, because when we take a trunk, it is configured at two ends. So we have, because the trunk is essentially between two switches. So if we have a trunk between two switches, at both ends it needs to be configured. So at both ends it needs to be configured correctly for it to communicate correctly. So when we are configuring at both ends, we should be able to configure the native VLANs correctly. So if we say on one port, if we set the native VLAN as 99 and on the other one we set it as 100, so that could lead to some issues. So if we set one end as a trunk port and the other one as an access port, so that could be a problem, because we want to set the mode to trunk mode in both ends. But if we misconfigure in one of the ends, again that could be an issue. It will not function as a trunk. Then the third one is about the allowed VLAN. So at both ends we should allow the same set of VLANs to communicate, so all those can communicate across. If one is not configured appropriately, again it will not function as expected. So again, when we are particularly troubleshooting trunks, we will have to go into both the switches at both ends and verify that they are functioning appropriately. So when we think about these incorrect port modes, sometimes what can happen is with each, because like we are configuring different interfaces to do different things. When we have VLAN trunks, we set them as trunk enabled, and we are checking them. But if we make one of the trunks as access port, so if we configure them as an access port, then it is not able to carry traffic as it would carry when it is a trunk, because it's not able to communicate like that. So again, we'll have to change that configuration appropriately to make it a trunk mode connection. So if we have, again, when we are verifying incorrect VLAN configurations, again we can go and see what are the allowed VLANs for on each of the trunks and see if that is configured correctly. So In this case, we want VLANs 10, 20, and 99 to be allowed. But on one side, it's only configured with 10 and 99. So we have to change that configuration to allow all three and there. So once we have VLANs configured in our networks, the next thing that we will try to do is once we have configured these VLANs, they are essentially going to function as separate networks. So the student VLAN is a separate network from the faculty VLAN or the guest VLAN. So each of these are essentially now different networks. We can have different IP ranges in each of these VLANs and so on. So they are essentially different networks. So once we have these different networks, then we also need to have routing between these different networks. So because when we have more than one network, then the communication should happen through a router. There should be a routing component in our network that is able to handle this aspect. So when we have this network with VLANs, this is another layer of configurations that we'll have to do or setups that we'll have to do for the routing part. So initial VLAN setups and everything we do on switches. On switches, we configure the VLANs, we configure the trunks, we configure the ports. So that is what we do on switches. Then we go to the routers, and then we'll have to appropriately configure. The routers will have to appropriately configure to carry traffic across these networks. So when we think about inter-VLAN routing, it is essentially carrying traffic between different parts of the network that belongs to different VLANs. Say for example, in this case, PC1 belongs to VLAN 10, PC3 belongs to VLAN 30, and if these two needs to communicate, that communication should go through a router because these are two different networks. Even if they are connected to the same switch, they are essentially connected to two different networks, or essentially two different networks. So we are not able to do a typical layer 2 switching here. They are essentially connected to the same switch. The physical network is the same, but still the communication should go through the router. So any communication between PC1 and PC3 will happen like this through the router because they are essentially two different networks. And to do this inter-VLAN routing, there are a number of different options. One is known as legacy inter-VLAN routing, the other one is router on a stick, and the third one is layer 3 switching using SVIs. So we'll look at each of these in a bit more detail now. So legacy inter-VLAN routing is essentially when we have a router and we have a switch that is going to connect to the router. So within our switch network, we will set up all the trunks and everything, and they are all able to communicate VLAN traffic or carry VLAN traffic accordingly. But then the switch that connects to the router will have separate physical interfaces for each VLAN. Say for example, in this case, we have VLAN 10, VLAN 20, and VLAN 30. So when we are connecting to the switch, for each of the VLANs, we will have separate physical interfaces connecting to the router. So for each VLAN, we will have separate interface on the switch connecting to a separate interface on the router. So on the router side, it's not particularly different because we will configure this link that is going out from the switch to carry only traffic belonging to a specific VLAN. So it will be only that. On the router's end, it will take it as a specific network coming from a separate part of the network. It may not know it is coming from the same switch. So similarly, we'll configure the other interface also differently for the other VLAN. So again, it will be part of a different network. So the IP addresses will be configured according to the specific VLAN network. So that would be fine. But the problem is when we have large number of VLANs, say if we have 10 VLANs, now we need 10 ports on the router and 10 interfaces on the router to connect these 10 physical connections. So in this case, for example, we have 2 physical connections connecting to the router from the switch. If we have 10, we need to have 10 interfaces. So that's the legacy inter-VLAN routing. So essentially, from the router side, it is going to be attached as separate networks on separate interfaces. Even though they are going from the same switch, they will be sent through different physical interfaces. So to configure a legacy VLAN routing, what we need to do is we need to identify the router interfaces that we are going to connect to. So we take 2 different router interfaces and we will configure those router interfaces with appropriate network addresses belonging to those VLANs. Because like one interface is going to be a specific VLAN, the other one is going to be another specific VLAN. So we'll have to configure those interfaces with IP addresses that belong to the subnet of the specific VLAN. So from the router's end, they are essentially belonging to that network. So in a way, if we had say 2 networks, we have another switch that is connecting to the router. How it may have operated, it is going to treat that interface in a similar manner. It is not going to particularly treat it any differently, even though that connection is originating from the same physical switch. So when we are configuring on the switch side, we will configure them accordingly. So on the switch side, we will configure which interfaces are connecting to which networks, and we will configure that interface connecting to the router also with the appropriate VLAN ID. So for example, here we have PC1 and PC3 belonging to VLAN 10 and VLAN 30. So interface 11 is VLAN 10, interface 6 is VLAN 30. So that is on the device side of the switch. So then when we look at the connection to the router, again interface 4 is going to be configured for VLAN 10 and interface 5 is going to be configured for VLAN 30. So now when any communication that goes to the router, that particular link is only going to carry traffic belonging to a specific VLAN. So that's the configuration that we will do there. Then on the router side, the configuration is not particularly difficult because now these are two different networks connecting through two different interfaces. So we just need to configure the interfaces appropriately. So we need to configure the interface with the correct IP address belonging to the subnet, and that's all we need to do. So we go into the interface, set the IP address for the interface, say one is 10.1, the other one is 30.1. So those are the gateways for those two subnets. We configure that, and that's it. So on the router side, there's no specific understanding or information about VLANs configured in this case. So with this legacy inter-VLAN routing, it's a very simple configuration from the router side of things. Even on the switch side of things, it is fairly simple because we are just configuring the interfaces ports appropriately. But the problem is when we have more than, say, two VLANs, or like if we have, as I said, like say 8 or 10 VLANs, so we need to find 10 physical ports on our router to attach all these separate networks, which can be inefficient in many situations. Yeah, and as someone mentioned in the chat, it's also it can be significantly inefficient. Say if we take the example of a university or that type of an environment, sometimes there will be different parts of the network where different VLANs may exist, and other parts their VLAN may not exist because, like say sort of admin staff type of a VLAN may not exist in all buildings. So similarly, there may be different differences like that. Different departments may not exist and exist. So then when we are routing through this type of an approach, there can be additional disadvantages from a physical cabling, physical infrastructure point of view as well. So to combat these disadvantages, we have an alternative mode, a configuration option, which is known as router on a stick inter-VLAN routing. So with router on a stick inter-VLAN routing, here the main difference is now the router is also going to know about VLANs. So when the router is also can know about the VLANs, now we don't need many separate interfaces interconnecting. We can just configure the same physical interface. So we use the same physical interface to interconnect between the router and the physical and the switches. Then with that same physical interface, how we configured, say, trunking on the switch side, on the router side, we will configure what is known as sub interfaces. So in this case, we have G00 is the main interface we have. There we would configure number of sub interfaces as .10, .20 and .30 belonging to each of the VLANs, and we will configure the IP addresses for these sub interfaces. So this is something as an additional configuration on the router side, and the router also needs to have the ability to work with VLANs, and the connection between the router and the switch is also now configured as a VLAN trunk with VLAN tags being carried across to the router itself. Because in the legacy inter-VLAN routing, the VLAN information stopped at the switch level. Beyond the switch, the router doesn't deal with any VLAN stuff. Whereas here, the router also deals with the VLAN information. And then the sub interfaces on the router are configured according to these different subnets of the VLANs, and then the routing will happen through that. So here what we need to do is we need to first set up the trunk between the router and the switch to carry traffic belonging to all the VLANs. Then in the router, we have to configure the sub interfaces belonging to each of these specific VLANs, the subnets of each of these VLANs. So on the switch side, earlier we configured all of the interfaces as access interfaces with VLAN tagging, whereas here we configure the access interfaces and the other interfaces are configured as trunks. Or the interface going to the router is configured as the trunk. And then on the router side, we'll have to go and configure the sub interfaces with the appropriate IP configuration. And uh, uh, to support VLAN, so if you want to work with VLANs on these interfaces, on these sub interfaces, we have to additionally configure what is known as .1Q encapsulation on that particular sub interface, so that we can associate a particular sub interface with a specific VLAN, because all the things are coming through the trunk. So from the router end, now we have to separate that. Here we have to separate that into each of the sub interfaces. So each of the sub interface should be tagged or should be identified with a particular VLAN ID. So that's what we configure with .1Q configuration. So then once we have configured this, now even on the router side, we can verify the VLANs, if the VLANs are configured correctly. And once that is done, on the router side, now we will also see all of these VLAN networks as separate networks connected to the routing network. So if we go to show IP route, now each of these sub networks will also show with the interfaces, with the sub interfaces. Then we can also do, because now essentially all of these are separate networks. So all of these are will function or will behave as separate networks, and then we can do all the verification between these different devices as we would do even with a physical network. So that's actually a sort of brief look at VLANs. So that is why we use VLANs and some of the implementations of VLANs on the switch side, and also some of the implementations on the router side as well. One of the things that you would come across later on is that VLANs being a significant part of most enterprise networks these days, and even on the course in the course in next semester in distributed networks also we will revisit VLANs again, particularly talking about layer 3 implementations, layer 3 switches, using layer 3 switches that also support VLAN, and how some of those further implementations can be carried on. So VLANs is an important topic regardless, even when you think about most, because like there's a good chance many of you would even work with cloud-based networks as we go along. In even now, many of the networks we work with are sort of cloud providers, their networks and all that. So again, VLANs, working with VLANs on those environments is also very common. So just make sure you have a better understanding of VLANs, a basic understanding of VLANs, because it can be very useful as you go forward. So are there any questions on the things that we have discussed today? There are no questions. We may conclude for the day. We will continue same time next week. Until next time. Bye. Thank you.